Welcome back to Smith Coating and Design. So in this week, we're going to make a fourth axis part. Here is the finished part. This is a pump top for a DDC water pump that would pump water coolant in your PC. So some interesting aspects about this part. So the first one is the G1/4 threads. So I actually had trouble finding a tool to cut these threads. Interestingly enough, the BSP, or the British Standard thread, this one in particular uses a 55-degree thread angle. And again, the only place I could find a thread mill that had a 55-degree angle was through Datron, and that cost me a little over $100 just for that thread mill so that I could make these threads. Also, what's interesting is with the G1/4 threads, they use an O-ring to seal, so they are a straight thread. Normally I buy my thread mills through Online Carbide. I get them for around $25 to $50 a piece. And that would be, like, for example, for these M4 threads down here. Sorry, let me go to the other side where they would connect to the water pump as shown here. And so there are some other, I'll say, some learning experiences or some issues I had to overcome with the fourth axis machining. So the number one thing, let me go ahead and pull the other one that is assembled on the DDC water pump. So you'll see here, when you do the part off, you have this side with these ugly tabs where you broke your part off when it was finished. So to solve that, I simply put my part in the vise, and then I just came down and took 5/1000ths off the top to give me a nice smooth contour. So that's how I did that. Another, we'll say, learning experience was just chamfering, which was unexpected for me. So if you imagine your part is sitting on our vise like so, you have to go around and chamfer the outside contour. We have this big block of material that sits back here. So to get around that, you really need to do a 2D contour and make some relief passes to give you just enough to make your 2D chamfers without removing too much material that would again negatively impact the rigidity. So again, I hope you find this cool. So that's what we'll be doing in this week's tutorial. I'll be doing a series where I prototype a bunch of PC parts. And again, I haven't tested this pump topper yet. If we look back at the assembled version, the reservoir would be here, so your coolant will get sucked in through the top and then kind of spit out the side here into your coolant loop. So again, that's what it sort of looks like. And I think in the future, I'll go ahead and make a custom heat sink, which is all this bottom part is. It actually lifts off if you unscrew the M4 thumb screws here. So again, I'll probably do some distro plates and various computer components just for some R&D for some potential future products. I do have a laser engraver now, so I'm hoping to be able to do some cool things with that with acrylic. So hopefully we'll see that in the future and maybe expand some of the content we have on the channel. Anyway, guys, I hope you enjoy this tutorial series, and I will see you soon. All right, so before we jump into the cam side of things and do the setup, I figured we would go ahead and just briefly look over the model in Fusion 360. And again, I will provide this in the description. So there's not anything too complex in terms of geometry. Really, the most complex part would be all the threads that need milled. So we'll just look at the underside here where you can see the inlet and then the outlet. So what I did want to mention here is, so why does this make a good candidate for the fourth axis? And so if we look at this, so if I were to flip this on the bottom side here and I was to do this traditionally, this would be my op 1, and then I would have to flip the part over in my vise, and then this side would be op 2, and then because we have this hole here on the top side, that would be the op 3. So really, I think there would be 3 operations if we were to do this traditionally. And by using the 4th axis, let's go back to the home view here, we can do basically all the main machining in 1 op. I'll say it really takes 2 ops, because if we go to the back side here, you remember I showed those ugly tabs where you do the part off, and really I'm going to say it's 2 ops, because once you break the part off of the 4th axis, you really want to go through here. And again, I just took 5/1000ths from the back side here to clean up where those tabs are. So you're probably going to want to do that cleanup in some way, you know, whether you're tumbling, brushing, polishing the part, however you want to do it. Me, it was easy just to go ahead and take 5/1000ths off. So you will need to do that. So another learning experience for me here, and what I was slightly wary of when I was doing all the thread milling, if we go to the vise fixture, so here it is on our self-centering vise with our parametric stock. So it's 4 inches long, 2.5 inches wide, and 3/4 of an inch thick. If we go to the right hand view, you can see that our stock is basically a large lever, and the vise is holding on to a very small portion of the stock, albeit there are some teeth on the vise jaws that help hold it. So one of my concerns would be, how much deflection am I going to see in my part when I'm doing the drilling operations before I go ahead and thread my holes? So you remember the 4 M4 holes and then the giant bore in the center. So I wasn't sure how much tool pressure I would be putting on this lever and then potentially causing issues. And the thing with the M4 thread mill is it's so tiny, if you're off by even a little bit, you're going to shatter a $50 tool. So that was one of the things I was slightly wary of when I was designing this part and performing all of the tool paths. Luckily, I didn't run into any issues. The drilling went fine in the vise, and for the larger holes, the G1/4 holes on the top here and then on the side, I just use a 3/8 end mill, which we'll see here in a few, and just use a boring cycle to go ahead and make those, because I didn't have a drill large enough to make those holes. So hopefully that helps. So next what we'll do is we'll go ahead and we'll get into setting up our part onto our fixture, and then go ahead and get into all the tool paths and walk through those. So thanks for tuning in. I hope this helps, and I'll see you through the series.